Recording.
All right. So our next project is the Hunch washing machine, and this is a total of 7 projects altogether. So you can choose any one of these to work on as a project, and what you're trying to do is develop the very first washing machine for zero gravity. So one of the options, so let me back up. Right now on the International Space Station, we do not wash clothes at all. We send up some clothing. The crew wears it for an extra long amount of time, and then once it's really dirty, they put it into the trash and it gets burned up. So they don't wash any of the clothes at all. However, when we start going to the moon and Mars and beyond, we're going to need a washing machine. So at some point, we have to explore this option. And you as Hunch students may get to be part of that if we can develop some really good ideas here. So what we're looking for is the basic idea is as simple as if I take a dirty shirt and I put it into the sink and kind of rinse it around in some water, I wring it out, and then I hang it up in the sun where the sun will kind of help kill off some of the bacteria and things like that from UV light, and then it gets dried off. That's basically what we're trying to do. And what we're looking for in some of these options are, so we have to come up with a way to get the clothing all wet. Then we need to come up with a way to agitate it, to kind of scrub it a little bit and kind of get some of the dirt kind of washed out of it a little bit. Then we need to come up with a way to remove that dirty water. And then we need to come up with a way to take that dirty water and kind of suck it out, and we need to send it off to the system that's going to clean that water. Okay? So there's first we have to remove the water from the clothing. Then we need to take that dirty water away from the clothing. And that sounds like it's one step. In gravity it is. In zero G it's not. Okay? Then we need to disinfect and deodorize, and that's going to be like some LED lights to be able to kill off bacteria with ultraviolet light. And then we have some rollers that have to take it out of the system and deposit and make it so that the crew can grab it. Now notice we're not drying it. We're going to dry that outside in the cabin. So the astronauts are just going to let it dry in the open air. Okay? But then the last component is probably one of the most important ones, is we have to have a control system. And some of this I think can be done either with a Raspberry Pi or an Arduino. And so if those are your kind of interests, if you like to do programming, not only do you have to understand the whole system, what people are going to need, but you're also going to have some ability with electronics. So this is a very exciting project, just because this is just exactly how we design things at NASA. We don't have one person that designs up the whole thing. We have lots of teams that have to work together to come up with an answer for each of these different segments of a system. Now, I've already had a couple of people ask me, can I work with another school on this? And the answer is yes. Now, I don't have a good way of how to work with the other schools or other teams, but you're welcome to work with other people. That's actually part of the intent for this, is that you're teaming up with other people to come up with the best answers that you can. And in the end, that's what we're going to be doing, is taking some of the best ideas around the country and try to put them into one system together so that they all operate together. If you think of this, think of the operation kind of like if I take a dollar bill and I want to get a piece of candy or out of the machine, I'd take that dollar bill and it gets pulled into the machine and it goes through several rollers. It gets inspected and checked and whatever. And then in the end, you get your candy. But what we want is that dollar bill goes through several different rollers and checks or whatever, and then it comes out as a clean dollar bill or a clean shirt. So it's going to be something like that. And one of the most difficult parts about this is that we have to make it fit into a very small box, right? So imagine something like a large printer that you might have in your classroom. It would be similar to that. So we have to try to fit your ideas along with everybody else's into a fairly small machine to be able to wash a shirt and then be able to send it out back to the astronaut so that they don't have such dirty clothes. All right, we'll talk about this more on the Hunch website. We have a much more detailed presentation. Make sure you look for that. Okay, next slide. Now, we've been doing food preservation for the past couple of years. This is another year where we're encouraging people for the same kind of reason, is that right now we're wanting to start thinking about sending food out to other places, right? So just like you like to have an apple or a carrot or whatever it is every couple of days, so would the astronauts. But right now, fresh food doesn't have, we can't hold on to it very long. We can send it up and it gets eaten within about a week. But if we want to send up a whole bunch of stuff so that they can go to, say, Mars, we need to be able to hold on to that and keep it good for a couple of months or more. And so if you have some ideas about how we can send up an apple, send up a pear, carrots, things like that, so that they will last longer and be able to get all the way to Mars so that they can enjoy their fruit better, that's what we're looking for. And remember, we need to try to keep the packaging small so that we don't have a bunch of trash. And also, we don't want to introduce new materials that might be hazardous to the atmosphere of the space station. Okay? So these are things that, this is much more about a future mission rather than just about what's on the ISS. So this is really very much about the future. Okay, next slide. Now this is a new one that I'm really excited about. Allie came up with this, talking about how, you know, if I have like yogurt and I want to have something crunchy in there, it's if I take some of that granola and try to shake it into there, of course, in zero gravity, it would just get all over in my face and into my eyes and things like that. I could inhale it, so that's a bad thing. We're looking for some kind of a package where I can keep my my yogurt or whatever my soft, moist material is, and my kind of crunchy and loose material, and be able to mix them together without opening the package, so that none of that loose particulate would be able to get into our faces or anything like that. This would allow the crew to have a mixture of, you know, things that are soft and moist with something that's crunchy. I think that there's a lot of other applications. I mean, here we have two examples. We've got, you know, some apple strudel and, or I mean, like a what do you call it? Just kind of an apple food with, you want something that's kind of soft and hot, but something that's also crunchy to go with it. So you've got a mixture of textures in your mouth. We would like to see that same kind of capability for the astronauts. Okay, next one. Okay, so the next three are the software projects that we have. Now, these are a little bit, these are from last year, but we've gotten some new requests on these. So right now, these are specifically for ISS, but there is a need for them on these new vehicles that are going to be going to Mars, that would be going to be in orbit around the moon. So these are some of the things that we could be using far into the future, not just on the International Space Station. And so we've got crew personalized mission reminder tool. Next slide. Augmented reality object identification annotation tool. And then also the last one, the automatic location stowage tool. These have all been topics of discussion for some of these new vehicles. So please check out the other presentation on this. We have Steve Hillinis that'll be giving you better definition of what we're looking for on that. Okay? And I think that's all of them. Is that correct? Okay.
Yes, that's it. We can stop the recording now.
Excellent.